Now that we've talked about elements, I'd like to talk about how we organize elements into the periodic table, and how to navigate the periodic table and then how to extract information out of it. Being able to do that will help us kind of put the pieces together for looking at overall structures of molecules. So the periodic table, which hopefully you've seen already, but it's really just a way of organizing the elements. And honestly, there's a lot of different ways you could organize the elements depending on what themes you think are the most important to highlight. And so I actually have a few of these here on the screen showing different periodic tables that have been created over time. I think my personal favorite is the one that looks kind of like a Star Trek insignia or something like that. But we don't use any of these. They have a focus on a kind of a different piece of these elements than the one we use in our class, and that most chemists use, except probably the people that made these ones. But like for the shared language of chemistry, we use what we call the modern periodic table. And here is a representation of it here at the top. And it is extremely long, right? Like it's organizing elements based on their outer sphere electrons and the way electrons are organized in the atom. Um, and so with that, we kind of get this kind of long, skinny periodic table. And so to simplify things, we've actually taken these elements right here, the lanthanide and actinides, and we kind of like put them underneath the rest of the periodic table. These are really heavy elements that are not commonly found in labs or out in nature as much. And so since most of the field really depends on the elements up here in the top part of the periodic table, we make it fit on an 8x11 piece of paper by just shifting the lanthanide and actinide series down below. And you get something that looks like this. So here is our periodic table of the elements that we'll be using. There's a lot of different versions of these out there. I strongly recommend, if you want one that's online, that's amazing, the dynamic periodic table, because you can kind of look at all sorts of different things about it, and it links to Wikipedia, and it's lovely. So here in this periodic table, we're going to kind of now start talking about how it's organized, and we'll kind of dive deeper and deeper and deeper into that. So first looking at this, let's talk about the rows and the columns. So we can see that as this is organized, we have columns and we have different rows along it too. So we've got this square grid. It has a kind of a shape other than that. So the rows across are called periods. And the columns are called groups. And so these rows and columns are going to have significance in the number of electrons in the atom and how those electrons are arranged, which we'll touch on a little bit here. But first, let's kind of break this up into some more broader categories. So each of these boxes represents, so each one of these right here, so like we have this one right here, represents one element. This element right here is actually hydrogen. So each box in the periodic table is representing a different element. So an atom or bunch of atoms that have different numbers of protons. So as we go right to left across our periodic table, let's use a different color. We increase by one proton. It's left to right and then down. So we have one proton here for hydrogen, And then we have 2 protons over here for helium. So we went over to the next element in the row, the period, and we had to kind of like have a lot of empty space along the way. So then we continue down onto the next row. So we have 3 protons for lithium. That was our example before. And then 4 protons for beryllium, 5 for boron, 6 for carbon, 7 for nitrogen, and we could keep going, right? So that's how it's kind of organized in terms of elements. And then within this, we also have what we call, there's like a special category called the main group elements. And these are the ones we're kind of focused on the most. These are ones that as you increase the number of protons, like the number of electrons in their outer sphere increase. That won't mean anything to you until we explain it later on. But I want to highlight where they are on this periodic table. So let's pull up a different color. Let's go with blue. So the main group elements are going to be these first 2 groups right here and the last 6 groups. So there's 8 of them. All right, and so these are the main group elements. They're also called the representative elements too. You'll see them referred to that as well. This will be most of the elements that we talk about. The other ones are categorized as, I can change my color. This block right here, these are the transition elements. And down here at the bottom, we've kind of mentioned these already, but these are the lanthanide and the actinides. For this class, most of the elements that we're going to be talking about as we look at different chemical structures are going to be in this upper part of the periodic table and the hydrogen right here. And that's because we'll be looking at organic compounds. These are ones that are primarily based on carbon, hydrogen, and oxygen. And so that's why our elements are going to be closer up there around those. So that's kind of like the basic outline of the periodic table. Next, we're going to look at the each of the individual boxes in the periodic table, what these look like. So I've increased one. Here's carbon. So basically I took the little box from the periodic table of carbon and blew it up here. So this is what most periodic tables look like. And so let's break down what we're seeing here. So first we're seeing the element's name, carbon. Sometimes periodic tables will put it on the back of a page, which is always kind of frustrating. The big C right here is the element symbol. This is actually just the abbreviation of the element name. This is also the symbol we'll use when we're writing chemical formulas. So we'll use that a lot. Then we have the atomic number up here. And it may be written below the element symbol, honestly. But you know it's the atomic number because it's a whole number. There's no decimal place. And remember, the atomic number is telling us the number of protons. In this element. All right, now there's one more number on here, right? There's this number. This number has a lot going on because it's got a lot of decimals. So this right here is the atomic mass. And I know I mentioned when we talked about isotopes mass numbers, this is something different, but similar. So this is going to be the mass of one atom. So this 12.011 represents the mass of an atom. And so it can be the mass of just one atom, or we can also, the same number is going to be the mass of lots of atoms, which is weird. And there's a very long conversion I can show you if you want, if you don't believe me. But it represents, for the mass of one atom, units of atomic mass units, which are just like really itty bitty like increments of mass. So 12.011 atomic mass units would be the mass of one atom. And then we could convert this into grams, but it's easiest to kind of do it for like a pile of it. And so we have kind of this baker's dozen in chemistry called a mole, and it represents 6.022 times 10 to the 23rd things. And so if we had that many atoms of carbon, it would weigh 12.011 grams. And I know that's a super specific number, but it makes things work out so that 12.011 is atomic mass units, or it's 12.011 grams per mole, which I know can be a little bit confusing when you're first learning chemistry. So we'll use that number with all the decimal places, the atomic mass, to calculate how heavy an atom is, and use it to then calculate how heavy a molecule would be. So that way, if we want to like weigh out a certain amount of a molecule, we can actually know, based on its mass, how many of the individual molecules we have, which can be really useful. And it's different from that atomic number that's just telling us the number of protons that are in it, which is, roughly about 6. So I would imagine that most carbon atoms have about 6 protons and 6 neutrons in them overall, because that 12.011 is really close to it being 6 plus 6, which would be 12.